All right, we are going to day 3. That's where you're at, right? Okay. And we're going to look at our daily checks. We have the first one. A container is shaped as a cube. It has a volume of 216 cubic inches. What is the area of one face of the container? Ben, where'd you start on this one?
You cube root 216 and you get 6.
Okay, why did you cube root 216?
Because it says cube and volume and cubic inches.
Very good. So the cube root of the volume will give you 6. And what does the 6 represent?
One thing of 3 of, like 6 times 6 times 6, or 6 to the third power.
So the length, the width, and the height? Okay, so that's an edge length or a side length. All right? But the question, if you look at it, wants the area of one of the faces. What shape are the faces of a cube? Squares. So if the edge is 6, good. We need to find the area. So how do you find the area? 6 times 6 or 6 squared. Good. And I heard 36. What would the unit be on this? Chloe? It is, but it's area.
Inches squared?
Inches squared. Very good. All right, the second question, we're going to compare and order those numbers. And we have decimals, we have fractions, and we have a square root. Absolutely.
Okay, so first you have to work out the ones that are not in decimal form.
Okay, so the
8 squared,
square root,
yeah, equals 2.8.
2.8.
Oh, well, 2.8 something, 2.828.
Okay, we'll just leave it there because since it's a decimal, it's irrational. Okay?
And then you have to work out the fraction. And then,
Okay, so 2 1/4 is how much?
2.25.
Correct. Oh, this didn't really tell us which order to list them in. So what did y'all just choose to do? All right, we'll do least to greatest. That'll work for me.
And then 2 1/4 is the least.
You are correct.
Then 2.3 repeated.
Now that's 2.3 repeated. Okay.
And then 2.5.
Okay.
And then 8 squared.
Square root.
Well, square root.
Good. And notice when he did it, he corrected himself and he put everything back in original form to do that. Very good. And some exponents. So we love exponents. They're our favorites. Not really. All right, Chloe, you want the first one? All right, how did you do the first one? All right, which ones did you put as like terms? Because I know you got a 3. Okay. Okay, so what's going to happen with the 3? Okay, what about the x's? Okay, so we kept the base and added your exponents. And the y's? Okay, so keeping the base, adding the exponents. So you had 3 x to the 7th power, as you said, and then y to the negative 2nd power. Now, it does tell us that we have to write this using positive exponents.
Yes, sir.
Okay, which one needs to be flipped? Okay, so this one needs to be flipped. And what's the final expression?
3 x to the 7th power over y to the 2nd power.
Excellent job. Very good. How about the next one?
Is that the one at the bottom? Which one?
Let's do the top one. What do you think we need to work first? The parentheses, because what do we notice about the parentheses?
It has a 0 exponent.
Okay, there is an exponent on the outside that happens to be a 0 exponent on the outside. So what does the 0 exponent on the outside do to everything on the inside, Brissa? So the entire part is a 1, right? All right, so if I rewrite this, I have 2x to the 3rd power, y to the 3rd power, and you just said that that 0 exponent makes the whole thing a 1, then I'm just multiplying by 1. So what's the answer? Exactly. 2x to the 3rd power, y to the 3rd power. And it's all because of that 0 exponent. You want the last one? All right, I'm going to move this up just a little bit so we have some room.
Okay, so, you can't have a negative exponent, so, I just brought the, wait, no. No, I don't wanna do it.
Ayla?
Since there's a negative exponent at the bottom, we do.
Can I make a suggestion? When we did these and we were doing this unit, I recommended to you guys to do the flips last. Because what needs to happen first if we flip last? There's still some math we can do because we have things that go together. Chloe, what's something that goes together on this?
The v to the v to the 1st power, v to the 3rd power.
Okay, the V's go together. Y'all spotted out the U, and it doesn't have anybody, but you also have these 2's. Now, it's a division problem. So we have 2 over 2, which is what?
1.
Yeah, that's 1. So do I need those 2's?
No.
Not particularly at the moment. I don't have anything with that U. I have U negative 3. But how about the V's? How do I use my exponent rules here, Brissa? KBSE. Keep the base and subtract them. So 1 minus 3, and we get negative 2. All right. Well, it's a fraction. Where's the U needing to be moved since it's already on the bottom? We got to move it to the top. That was something you guys honed in on immediately. But where's the V going to go? The V is going to go on the bottom. Is the 1 a needed piece? No. Very good. The more we keep these practicing, the easier they're going to get. All right? You just can't forget about them. All right. We've been studying this whole don't call me after midnight. It's kind of our memory thing on solving multi-step equations, where we've been distributing, then combining, and then shifting the variables so that it's on the left side of the problem, correct? All right. I have these two equations, and I want to give you about 90 seconds to 2 minutes, because it's not going to take long, because you guys are getting really good at these. I want you to solve them and be ready to discuss some things that you see about them. And I'm going to pause the video so you guys can have some chat time. Okay, so if you're sitting here working these out, some really weird things should be happening as you solve these equations. Okay? What did we notice started happening maybe with the variable?
They doubled.
It what?
They were like the same thing.
The variables ended up being the same thing, and when we moved the variable over, what happened to it? It canceled out. Okay, that's actually important to what we're doing today. So let's look at this first one. I saw a lot of great combining of like terms with the 2x, hold up a second, and the x, the 10, and the 5. Okay, so we had 3x plus 15 equals 3x plus 15. Okay, so first of all, what do you notice about this? The left is identical to the right. Something to keep in mind here. Okay? But what one was just said was that when we moved the variable from the right to the left, the variable completely canceled out of the problem. And you were left with 15 equals 15. So now we're sitting here going, this is a little weird. All right? Well, what happened on the other problem? We're going to hold on that one. We're going to look at the other one. And what would our first step be on the right side of the problem? Okay, so we're going to distribute on the left and distribute on the right. What's the left expression going to be?
6x plus 15.
Okay, so 6x plus 15 equals, on the right, 6x plus 6. Okay? And we get rid of the right side variable using its opposite. We do the same thing on the other side. What just canceled out again? Not the exponent, the variable. And we're left with 15 equals 6. All right, here's where we run into something. Which side of those is a true statement? The one on the left, because y'all, we know that 15 is equal to 15, right?
Yep.
Okay, when the variable cancels completely out of the problem like this, if the last statement is true, 15 equals 15, we said that this has infinite solutions. What that's telling us is that any value of x in the real number system is an answer here. All real numbers can solve this problem. Every one of us could pick a different value, plug it in for x, and the left would equal the right. Yep.
So if I put 80
If you put 80 in as for x, you will get 80, 255 on the left and 255 on the right. It'll work that way. It's crazy. But now we look at the right side. Now, the right side is not a true statement. 15 does not equal 6. When the variables cancel out of the problem and the end statement is wrong, this is a no solution. That's telling us that there is no real number that can make this work. Not even 0. I plug 0 into this, and I'm going to get 15 on the right and 6 on the left. It just doesn't work. So what we've got now, and it was the title of our stuff, was what we've been working with up to this point. We've been finding x equals blank. We found a solid answer for x. Now we've got situations where when the x's cancel out, the variables cancel out of the problem, we either have infinite solutions or we have no solution at all. Okay? And let's be very mindful here. On the no solution one, do not tell me the answer is 0, because 0 is a number. Okay? You literally have to write no solution. Okay? Or infinite solutions. All right? Will you have stuff like this on your quiz? Yes, it would probably be multiple choice, and you'd be telling me, is it a one solution, an infinite solution, or a no solution? So here's what I want you to do. On your next slide, I've given you 3 equations, and I want to know how many solutions does each of these have? You only have 3 choices. One solution, no solution, or infinite solutions. And we're going to work them exactly as we normally would. And I just want to know, like, as you work them, can you maybe figure out a way to determine how many solutions without working the entire equation out? See if anybody can find the pattern, because there is a pattern there. And I'll pause it for a couple minutes. Okay, let's start looking at these. On the first one, the top left, what do we want to do first? We want to distribute. So we end up, we're recording, by the way.
All right, so we end up with
how much?
3x plus 12.
You are correct. So I have 3x plus 12 equals 3x plus 12.
Yeah.
All right. What did you do next, assuming we continued on this problem? Miranda?
Well, I just ended there. Started it there.
Why did you end it there?
Because on the other one, it was like identical on both sides. So I just put infinite solution.
I like it. She found a pattern here. Both sides are identical. This is one of those key things to keep in mind. Both sides of the equation are identical. They're not just equal, they are completely identical. Okay? The coefficient on the variables are the same. The constant is the same. So, as Miranda said, if the left is completely identical to the right, it's infinite solutions. That is one of the tells in this, okay? Let's look at the one on the right. You like that one, okay? Why do you like that one? Because it's got an answer. Some people like things that there's answers to. All right, Reed, what are we going to do?
So, you do combine terms that there is no way you distribute.
Yep,
There's no distributing or combining like terms.
Correct.
So you have to, well, this is what I do. Minus 2x on both sides to get to the,
You are correct.
and then that equals 3x plus 8 on that side. And it equals -1.
Correct.
And then you have to, minus 8.
Okay, so you worked out your problem.
So then minus 8 on that side equals 9, -9.
Correct.
And then you have to divide by 3 on both sides. That equals x equals, -12.
X is -3. So what did that just tell us?
Has one solution.
It has one solution.
I did one wrong, by the way.
Can anybody tell me where I can identify in this problem that there's going to be one solution?
Since you were to split it, like you would get, I'd have to get all the way through without having to stop for anything.
I was able to get all the way through, nothing canceled out of it. What else did you notice? The variables were what? The variables are still in the problem. Read.
I'll tell you what I stopped at. I stopped at 3x plus 8. And I made up one solution.
Okay, he stopped at the 3x plus 8 equals -1 because the x was on one side. It would solve itself to be one solution. Lyndon?
There's like only like one type of variables not the same.
If we go back up to this step right here, do you notice nothing in it's the same? Those variables are different. Their coefficients are different. That's your key here. One solution, your coefficient is different. What do I mean by coefficient? The number multiplying to the variable. The thing multiplying to the variable. If those are different right there, it's going to be one solution. Take it out one more step like Reed did. And now all of a sudden it looks like the problems we've been solving the past couple years. Now we look at the bottom one. All right, Chloe? Okay, combine like terms on the left side. And what did that give you when you combined these like terms? So x plus 10. Well, okay, but she didn't see any parentheses, so she skipped over distributive property. All right, what about the other side? All right, so we have 2x and a -x. Yeah, it's just an x. So 1x, so we have an x minus 10.
It's already infinite.
Ooh, it's not infinite though. Remember, up on the infinite, the thing that Miranda pointed out a minute ago is that both sides were completely identical. The coefficients and the constants were the same. What's the same on this? Okay, we have the same coefficient, but what's different? But different constants. What's a constant? Number that doesn't change. It's the number without a variable. If we continued to work that down, the x's would cancel out and you'd be left with 10 is equal to -10. A false statement. They don't have to be opposites of each other, okay? They just have to be different. But the variables have to be the same. Okay, so if we can get our problems through the distribute and the combine like terms portion, you should be able to identify the number of solutions if you remember those little patterns. If you don't, work them all out, okay? You'll end up with an X equals a number statement, or you'll end up with a true statement or a false statement. What does a true statement give me? Like 7 equals 7.
Infinite solution.
Infinite solutions. And then a false statement would give me no solution. Good. Looking at number 2, I just want to know how many solutions we have. And your explain, folks, that's our work. Okay? So we're going to work this one as far as we need to get it before we can make a conclusion. And I'm going to split my problem. What do we need to do on the left side, Jason?
Distribute.
Good. We're going to distribute the 3. And Jason, do you have us a new expression for the left?
It's 7.2x plus 12.
7.2x plus 12. Okay, anything else to do on the left? No, it's as simple as Jason likes to say, it's in its simplest form. The right side of the equation, any distributing or combining? All right, what terms do we need to combine? Okay, so we're going to combine those like terms, Ben.
7.2x.
And then we have a plus 7. Okay, what do we notice? Let's stop, let's take a look. What's some stuff that we're noticing, Jason? All right, we have the same coefficient, which means what's going to happen to that variable if I move it? It's going to cancel out. The constant is different. Okay, well, since the constant is different, what can we conclude? Lyndon?
Has no solution.
There is no solution. Very good. Very, very good. Any questions? We good so far? Okay. Let's try this one. We have 7x plus 3x minus 8 equals 2 times 5x minus 4. Huh? Ooh, Jason's already got us an answer. He says infinite solutions. Let's prove him right or wrong. Let's see what he's got. Where would we start? 7x plus 3x. So we're combining like terms. And what does that give you?
10x minus 8.
That is correct. Miranda, what am I going to do on the right side? I'm going to distribute. When I distribute on the other side, let's make sure that we keep that a negative 4. And when we distribute, what do we get?
It's 10x minus 8.
Very good. 10x minus 8. So was Jason's quick response correct? Oh, he said you were quick, but you didn't do your work. He did in his head. So right here would be our explanation. And what is our reasoning that Jason is correct on infinite solutions? Brissa?
Both sides are identical.
The two sides are identical. Good. So we do, in fact, have infinite solutions. Excellent. I think we're liking these more than the whole multi-step things where we have to keep on going. All right. Oh, it's a word problem. Oh my goodness. Okay, so Tom and Agnew are making desserts. Todd buys peaches and a carton of vanilla yogurt. Agnes buys apples and a jar of honey. They bought the same number of pieces of fruit. Is there a situation in which they pay the same amount for their purchases? Okay, so if they bought the same number of pieces of fruit, do we know how much fruit they bought? No, but they are both going to get the same what?
Number.
Oh, no, not number. Variable, because we don't know. Which variable do we want to use? X. All right, so the same number of pieces of fruit, you guys chose to use X. We want a situation where Todd is going to equal Agnew. And we worked on these recently, writing the equations where they were equal to each other. One says Agnew, one's, oh goodness gracious. Agnes, Agnew, it says both. All right, so I need to go back and fix a typo, but that's okay. Okay, so Agnew, Agnes. What expression would we use for Todd? He is buying peaches and vanilla yogurt.
X plus 4.
No, because we're talking about the cost. So there you go. The 1.25 needs to be on your variable because it's $1.25 per piece of fruit and Todd's yogurt. And we want it to equal Agnes or Agnew or Anne on the other side. What expression do we have for Agnes? Read.
You have 9x
1x
plus 6.
plus 6. All right, so we have this equation, and it's saying, is there a situation in which they pay the same amount? So if I look at this equation that's been written, it's down in the simplest form on both sides. Is there a solution, Ben? Yes. How do I know that I can solve this and get an answer?
Because none of the sides are the same.
Nothing on it's the same when it comes to those x's. So let's find out how much it's going to be. What is the situation? What do I have to do? Let's solve it.
Minus 1x.
All right, we're going to minus that 1x on both sides. Hold up. Hold up. All right, I heard Jason say 0.25x plus 4 equals 6. Chloe?
Minus 4, cast out.
You are correct. So I have 0.25x equals 2. Okay. And x is 8. So what does that tell us? What does that x equals 8 tell us of this problem? How much fruit they would have to buy in order to pay the same amount. Very good. Very good. We good? Just checking everybody's pulse, making sure we're alive and this is making sense. Number 5. I'm giving you an equation and I want to know if it's one solution, no solution, or infinitely many, which just means infinite solutions. So here's our equation right here. We have 33x plus 99 equals 33x minus 99. Ben?
No solution.
Why no solution?
There's a negative. It's not the same.
What's not the
I
same?
mean, you got your constant and your, not your constant. Your constant's negative and what's positive.
Okay, so the constants are not the same?
Yeah.
Okay, so the constants are not equal, but what do we know about the coefficients?
There is well.
The coefficients are equal. So if the coefficients are equal, the number with the variables are the same, but the constants are different, what's the end result? No solution. Yeah, watch the signs. Okay? Very good. All right, we're going to solve the equation. So we got people sketching it down. And when we go to solve this, what are we going to do first? Mathis? All right, we're going to distribute first. I know you have the answer. All right, so Mathis says distribute. And Mathis, when we distribute, what do we get as the expression? 16x plus 12. All right, that is in its simplest form. How about the right side? Ben?
17x plus
I'm going to disagree with your answer, but tell me what you did.
19x minus 3x is 9 plus 30.
Okay, so you combined as some like terms. I want you to check what 19 minus 3 is.
I think my calculator's broken.
The calculator's broken. All right, 19x minus 3x is 16x, and it is plus 12. And Jason, why can we stop here and know that there are infinite solutions? Everything's the same. Very good. Everything's the same.
I think I can start doing algebra.
He's,
You say what?
he's going to move to algebra. 'Cause-
You need to work out.
All right. How about this one? Number 7. 4x plus x plus 4 equals 8x minus 3x plus 4. Jason's liking this stuff. He's like, I can do this in my head.
I like this.
Yeah. Or don't get a bad one.
What's going to happen if I give you fractions?
Oh, I'm not gonna do that.
He's not going to do it.
But yeah, it's infinite.
All right, Q, explain how you came to the conclusion that this is infinite solutions. She is correct. Once you combine like terms, we have two equal expressions. So everybody in here, I'm pretty certain, got the fact that this is infinite solutions. A little abbreviating, never hurt anybody. All right. Okay, I'm going to give you a word problem. And I'm going to pause it and give you a chance. Use that previous word problem about, Agnes and Todd and their dessert making to guide you through this. And I'm going to pause it for you. Okay. We have our rival dry cleaners. And we have X equaling the number of items dry cleaned. Store A The prices are represented by the expression 15x minus 2. Store B, the prices are represented by the expression 3 times 5x plus 7. When do the two stores charge the same rate? Evan?
Oh, okay. So the problem will be, 15x minus 2 equals 3, parentheses 5x plus 3,
Plus 7.
yeah, 7.
You are correct.
Alright, and then you can, bring down the, 15x minus 2.
Very good.
It's fully combined, you can't do it anymore. And then, 3 times 5x is 15x, and then would be, alright, and then you'll subtract,
Now, hold up a second. What is the 3 times the 7 on the distributed property?
21.
Okay.
And then you're gonna subtract, 15 on both sides, 15x on both sides.
Okay, so you moved your variable over to the left.
And then it cancels out both, so,
You're right. So we're ended up with negative 2 equals 21.
there's no solution.
Okay, so there is no solution here. So my question says, when do the two charges charge the same amount? Never. If there's no solution, it will never work. Very good. All right, how many solutions does this equation have? Doing it in your head. What do we want to do first? Okay, so combining like terms on the left side of the problem. Okay, so Jason says we have 6x minus 7. And what are we going to do on the right side? Distribute. Jason, do you have that right side worked out for us?
It'll be, 5x minus 6.
Okay, if I look at this right here, the question says, how many solutions do we have?
1.
How do you know it's one solution?
Everything's different.
Everything on it's different with those variables. So this is a one solution problem. Yes, ma'am.
So we really don't have to work it all the way out.
It did not say solve. It just asked for how many solutions. So if we know our patterns, we're going to ease up our work because that shows us our answer. All right, number 10. Say what? You know, a question like that probably would be a part A, part B. Like the first one, how many solutions? And if it's a one solution, then the next part would be solve it. I could see something like that happening. All right, how many solutions does this equation have? Ben says 1, Jason says 1. They're not even doing any work, and they're like, hey, we have answers. Lyndon agrees with 1. Who can prove to me that it's 1? All right, Lyndon?
Because the left part of the whole thing is just left is 6x plus 12, and the right side is 5x plus 35.
Very good. Once you do the distributive property, 6x plus 12 and 5x plus 35. One solution is 100% correct. Oh, wait a second. Do the last one for me. Which of the following best describes the solution to the equation? Hand up if you could tell me if it's 1, infinite, none, or 2.
Yes, you did. Dang, bro.
And there are cases where there's 2 solutions.
Me.
Ooh, the hands are going up.
I'm reaching this long.
Reaching. Miranda,
Dang, bro.
I did infinite.
why did you choose infinite?
When I did the right hand side and should be, and then both sides.
Yep. Both of them come out to be 8x plus 12.
All right.
All right, folks, study up. You have a quiz tomorrow. Oh, by the way, the 2 homework sheets need to be ready to check tomorrow. We're going to check them over before our quiz, and then we'll take the quiz, and I think we'll do fabulously on it. This will be on it. All right? And the video will be posted for you momentarily.